So in this lesson we're going to be looking at quotients of radicals. And honestly, when we do quotients of radicals, it's more simplifying the radicals than dividing. Now at these first few examples we will be dividing, and that will be easiest when it's possible, but sometimes we don't end up dividing. We actually end up multiplying to help us simplify these quotients. So first couple examples, and when you can you should try doing this. The second part it talks about here, but when working with radicals, we've talked about simplest form before. You can never have a radical in the denominator, and that's just like common mathematical form. We don't leave fractions unreduced, and we don't want to leave a radical in the denominator. So the easiest way, if possible, is you actually do division. And here's the rule here, similar to multiplication, but if you take the square root of a fraction, it is the same as taking the square root of the top over the square root of the bottom. And we can think through this backwards. If we have a square root divided by a square root, we can actually divide the numerator by the denominator. We can put it under one radical. So here's an example written out. I know the work's shown for you already, but you have a radical divided by a radical. So we can write that as a fraction underneath there, and the reason we do that here is because we know that 3 goes into 12. So we have our division problem. We rewrite it as one radical. 12 divided by 3 is 4, and then taking the square root of 4, you get 2. So that's one example of where it's nice to be able to change that. Here's another one. This is another simple one, and I know the work is already shown. Square root of 6 divided by the square root of 25. Don't go through the trouble of trying to divide these. We know what the square root of 25 is. We know that's 5, and so we can rewrite that as square root of 6 over 5, and that is the simplest form we can put it in. We're not putting them in calculators and dividing to find a decimal approximation. We're putting in simplest form. Well, what happens if you can't divide? Then what we're going to do is we are going to use a process that a lot of times we call rationalizing the denominator. Here we have a 3 over the square root of 5. One of our rules is we don't want square roots in the denominator. So what we're going to do is we're going to remember that a square root multiplied by itself is actually just the number inside. And so we cannot just multiply the bottom by a square root of 5. We're going to multiply top and bottom by a number, the same number, because when we multiply the top and bottom by the same number, that's multiplying by a form of 1. So really we're going to be multiplying by a form of 1 when we work through these problems here. So let's go ahead and do this one. We are going to multiply by square root of 5. We want to use the square root of 5 because we know that the square root of 5 times itself is going to give us a 5 in the denominator here. But what we do to the bottom, we have to do the top, and what we're doing here is this right here is really multiplying by 1. So when we multiply by something by 1, it doesn't change the value, it just changes the form in this case. And so we end up with 3 times the square root of 5 over 5, and that is our simplest form. Our next example here really kind of uses a combination of the two things we've talked about. So we can divide here or simplify because 2 goes into both of these. So we can rewrite this as 6 and dividing the top and bottom by 2. This is really the square root of 7 over, once again, we have the square root of 5 in the denominator because we divided both by 2. We reduced here. We still don't want the square root of 5 here, so we'll do the same thing. It's not always going to be a 5. The last couple examples were, but we're going to multiply by the bottom by square root of 5 because the square root of 5 times the square root of 5 is simply 5. But we have to also multiply the top by the square root of 5, so we're really just multiplying by 1. And so we learned multiplication in the previous lesson, so we have a 6 here, and we can multiply what's inside the radicals, and 7 times 5 is 35. And then our last example of this type of problem is 2 root 3 over root 10. 3 and 10 don't have any common factors. You can't simplify here. Also, you have a 2 on the outside and a 10 inside the radical. You can't simplify something outside the radical with something inside the radical. So we want to get rid of the square root of 10 because we're not supposed to have square roots in the denominator. So we know that we can multiply the bottom by square root of 10 because the square root of 10 times the square root of 10 is simply 10. But what we do the bottom, we have to do to the top because we're multiplying by a form of 1. Now multiplying here, we have our 2. And then square root of 3 times square root of 10 is the square root of 30. We want to make sure we can't simplify anymore. Square root of 30 doesn't have any perfect square factors. But now we have these numbers that aren't a radical, and these can be simplified. We know 2 goes into this 1 time, and 2 goes into this 5 times. So our answer is the square root of 30 over 5, and you cannot simplify further here because this is under a square root and this is not under a square root. So that's the first part that we're going to look at, simplifying radicals.